or something's unclear, just be direct. Tell me, hey, you know what? This is the way it is. So this is the first graphing problem. Is this what you're referring to, graphing these sort of things, or something else?
Yeah, those are a pretty good example.
Okay.
And
Okay. So we'll start with this is graphing a linear function or a line, linear function or a line. And to do this, you need the slope and the b value from this equation here. Do you recall either of those? Can you tell me the slope or the b value?
Okay, slope is like rise over run, so I think that's the 7/2.
Yes. I mean, it doesn't have to be a fraction. It could be a whole number. What about the b value?
-2.
-2. So you start at the b value. So that's key here is you start at the b value.
Uh-huh.
And then like you said, the slope is rise over run. Now you go up when it's positive, you go down when it's negative. So from this point here, you're going to go up 7, 1, 2, 3, 4, 5, 6, 7, right 2, and your
Okay,
instruct.
so that's already one question I just want to ask for clarification. So when you have a rise over run, the one on the top is for how much it's going up, and then the
Up,
bottom,
yeah, up or down, and then it's always to the right.
and it's always to the right. Okay.
Yeah.
And it doesn't matter if the top is smaller than the bottom or vice
No,
versa.
no, and it really could be anything depending on the type of problem they give you.
All right, cool. And then,
Okay,
so my question is with the -2 that you're just treating that as like the y-intercept, right?
that's exactly what it is. The b value is the y-intercept.
Okay, so then on a problem like this, you move it down, or you move it down vertically by 2 units, and then
You start here. You got to pick a point along the y-axis to start at.
mhm, and then you
You use the
start
slope.
from there going up 7 units, and then you move to the right by 2 units.
Yes.
And then if it was -7/2 plus 2, you'd be 2 units above 0,
Right.
0,
Right.
and
So
you'd go down 7.
yeah, let's just do another problem here. I mean,
All
I
right.
think there's a lot there, obviously, and I know you like to verbalize things, but let's just do another problem here.
All right.
What is the slope? What is the b value? These are important
And this
things
problem is
to.
like y equals mx plus b.
Yes, we will do some more complicated ones, but we'll start with these.
And what's that called again? Y equals mx plus b.
It's called a slope intercept form.
Okay, slope intercept form. All right, so the m is your slope, so that would be just -6
Okay, and how about your b
over.
value?
Would you write -6/1? For
Yeah, and
that?
that I was going to get to that, but yeah, that and again that's important here. The negative should always go with the numerator, and that tells you you're going 6 down,
And then 1 to the right.
1 to the right. Yeah.
Okay,
What is
and
the
then
b?
b would be 3.
Okay. Again, that's the y-intercept.
Y-intercept, and you're moving. In this case, you'd be moving 3 units up the graph,
Yes.
and then with the -6, you'd be going. No, excuse me, you'd be going 6 units down, and then 1 to the right, and then
Yes.
I guess you'd technically do that for infinity, but.
You keep doing it forever, but they want to see 2 points. They want to see the arrows connecting them.
Mhm. And then so for problems like this, you have to make sure that you'll have the arrows and that you also label the points on the graph. And then,
That's a good idea. I mean, I think it's kind of clear if you're where you're putting if it's on the grid, but the point is to be as explicit as you need to be for your instructor.
yeah. Um, for this one, that's kind of it for this, right? Like, could there be more questions based upon like what that is, or?
Yeah, we should do this. We're gonna do 3 and 6. These are the exceptions.
Mhm.
Um, it's nice that you have the same teacher because you get a feel for whether they emphasize the exceptions or not.
Yeah.
You've already done this one correctly. Y equals a number means that it's a horizontal line
Uh-huh.
through that number.
Yeah, I still think when you taught me the like difference with horizontal and vertical, it's like horizon. That's
It's the horizon, yeah.
yeah, that's my go-to for it now.
Okay, and then the other one, the other exception here to remember, and you already have it correct here, is the vertical line, and you just want to you want to have this one down when it's x equals a number.
Uh-huh.
That's a vertical line through that number. You have it correct right here.
All right, cool. Those
So
are the
just so let me ask you just a short question here. Where and where is the point? It's a point. Where do the lines y equals 2 and x equals -3 intersect? Okay, so what I'd like you to do is graph both of those
mhm.
and then tell me where they intersect. Give me the point.
All right. 1, 2, 3, 4, 5. Negative. Oh, wait, that's yeah, -3 and 2 is their interception point.
Yes. And sometimes they ask you to, graph it. Uh
That's what I did, and I was like, wait a second, that's just normal.
yeah. Okay, but there it is. All right. Okay, so I noticed on your review packet thing, there's some odd questions here. They're kind of related to graphing, but let me grab one for a moment and see if we can. This is something. Uh, okay, so here's your function, and it's asking you to evaluate the function at 2 points.
Hmm.
Um, I don't know that we did much of this last year, but
Yeah, I don't think we have ever covered it. Yeah, one
so
thing right now I do want to say, my math teacher, she won't be here until September. I don't know why, but we have a substitute teacher for like half the week who used to be a teacher, and then we'll get random ones. So I think we might get like a difference. Like, I mean, how broad is geometry exactly? Like for how much different stuff people can necessarily hand out? Because like I'm a little
oh,
nervous that I might get like stuff that's really different compared
yeah.
to
Let me
math.
let me put a different kind of. Did you I know you've taken some tennis lessons. Have you taken tennis lessons from more than one person in your life?
Yeah.
And so it's kind of like that. I mean, they're
So it's like just little different
right.
thing. Like it's still the same premise, but it's like little differences with people.
Exactly. I'm sorry you have to go through that. It's not a doesn't sound like it's an ideal scenario.
Yeah, I mean it's all right. I I got you. So
Yeah, no, so you're gonna what you're gonna do is you're gonna develop your own habits, study habits, and uh, because the same thing will happen again generally, in your life. You're gonna take a class and maybe you have one teacher or a teacher leaves, or they even have these things called co-teachers where you have two
yeah,
teachers. College, sometimes you have a professor and then a teaching assistant with a class. Sometimes you take lectures where they give you a different presenter each week and they're always different. So
yeah,
what you have to do is realize like that's just noise and just you
yeah.
still need
Just
to learn the math along the
all
way.
right. Yeah, thank you.
So like when you look at a problem like this, this is the notation that's really important here. It's saying f of x equals y, and what that means is, and I'm going to give you the answer for the moment, just to help with this first one. So the number here means x equals 0. So you literally look at the graph where x is 0, and you go up or down until you hit the graph. And then this is the y value, y equals 1. It's literally that ordered pair there, 0, 1.
Hmm.
Okay. So let's do a different one of this because this one isn't even on the graph. It's silly. Let's do f of -1. This means that x is -1. So I'm going to do it in a different color here. You go to the graph, there's -1, and you go up or down until you intersect. What is that point right there?
The, I guess, intersection point of the graph. Oh,
I'm
negative.
giving it to you. I'm giving it to you. I'm not trying to. Um,
Negative 1, 3.
yeah. So f of -1 equals 3, and what that means is that y is 3. X is -1 and y is 3.
All right. So
Okay.
then that would, so x is -1, y equals +3. So then would you be inserting the -1 into that for an equation?
No, because you have the graph. Okay. But
Okay.
let's keep this going here. So I want you to find f of 0. And that means that x is 0.
All right. That would be 4 and 0
Nope,
and
nope. X is 0. X is 0 right there.
oh, okay. So
So what is the y value there? What is the y value at that point?
0, 0.
Just the y value. What's the y value there? You've said it, but it's just one number.
0.
0. Okay. All right. Now, how about f of -1? That means that x is -1. So you go to your graph, you find -1, and you go down until you hit the graph,
Mhm.
up or down. So what is the y value there?
The y value there is -1 and -2. I mean, sorry, -2.
That's right. So the y value is -2. Okay. So what I think is unclear here, and I'm trying to not make this more complicated than it needs to be, is you're just trying to figure out where you are in the graph.
Mhm.
Okay. So like what is f of 4? Okay. And again, that means that x is 4. X is 4. So you go over here to where x is 4.
Mhm.
What's the y value there?
The y value is 0.
0.
And then, so if the f value, could you make it something be like 6 or something like that, and it would still work the same, or did
Yeah.
you use 4 just because you can like see that right there?
I chose 4 because it was a nice point.
Um,
You want to do it when it's nice. Let's just keep this going here, and then we'll talk about the function for a moment.
all right.
So here's another graph. Okay. What is f of 0? I guess that's the only good one point we can do. And you say, okay, where, see how that means that x is 0. This is the x-axis here. So you go where x is 0, and you go up or down until you hit the graph.
Mhm. So
So
that
what
would
is
be 4.
4? Good. Try another one here.
All right.
Okay, so what is f of -1? F of -1, please.
I guess it would be uh like 2/3. Wait, sorry. Can I see the other one right
Sure,
before this?
sure.
All right, thank you. Because this is going from the 0, 0, correct?
Well, it's because x is 0. Because x,
Mhm.
that's why you start. In the previous
Oh,
problem,
so then
we did a bunch. We did when x
it
is
was
0,
like
but then x is -1, then
negative.
x is 4.
Okay. All right, I think I get that now.
So this means that x is -1.
So I guess that would be um -2.
So you're saying the graph hits right there?
Or I guess that would be 9/10, negative 1 and 9/10.
So like the picture is a little, but you literally start at -1. You go down until you hit the curve. It looks like you hit it right there.
Oh.
So what is the
Okay,
y value there?
I don't know. I wasn't like thinking now.
It's
Okay,
okay.
yes. So then if that one would have been +1, then that would have been like +4 rather.
Yeah, but what's the y value there? I mean that's what I keep. That's
The
what I'm
y
trying to get.
value is -4.
-4. Okay.
Okay, that makes a lot of sense.
Okay. So let me see if I can find a few more graphs to do this with. I mean, this really is important. Yeah. Okay. Here we go. Yeah. So it's -4 here. All right. So I want you to tell me what is f of 2.
It is 4.
Okay. What about f of 4?
+1.
Okay. What about f of 8?
3.
Okay. So again, these numbers in parentheses, those are the x values. These are the y values. Do you see that?
Okay, that makes a lot more sense now. I used to
Okay.
think it was like some like multiplication type thing.
No, it's just the
What the x value is.
yeah. Okay. So now this is where it gets confusing, and we should bring this up because it will come up here at some point. So exact same graph. Okay. Okay. This is the other type of problem that you will get. Okay. So I want you to go back up and look at this previous one. F of 2 equals 4. 2 is the x value. 4 is the y value. Now let's go down to this problem. What is 4? Is it the x value or the y value?
Yeah, y value.
So this time, this is where it gets confusing. This time you go to the y, and you figure out where it hits. So what is the x value?
2.
2.
Okay, so it's just flipped necessarily.
Yep. So now this one's a little bit harder to because there's multiple answers, but let me actually do a different one. So where is f of x equal to 7? Let's try that one.
F of x is equal to 7 at 2 and 2.5. X is 2.5.
So here's x is 2.5 right there. Is that what you meant?
What
is this number right here? 7.
It would be like, so the y value is 7.
So where is 7?
Oh my gosh, 0. Sorry, I was looking at
So this is the confusing part. This is truly the confusing part is there's 2 questions you're going to be asked. Okay. So let me try to summarize here. So here's the graph, and there are 2 questions that you could be asked. F of x equals something. So in this problem, they give you x. X is given. And then the other one is f of x. Actually, let me not do it this way. Let me change it up here. F of 2 equals question mark. X is given.
X is given, and x is 2.
Right. And here's the other one. Y is given.
And then that is 4. So then for the x, you're looking at the 2, and then you figure out that, oh, it's 4. The missing number is 4.
That's right. So the answer here, the answer on the left is that y is 4. On the one on the right, y is given. So you're trying to find x.
Yeah, you're looking at the y part of the graph. You find 4, and then it is also 2.
Yes.
Okay.
Okay. So here
that makes a lot more sense now.
Now we're gonna do this with functions, but this is the same idea. So let's say that f of x equals 2x minus 4. There are 2 questions I can ask you. The first one will be f of 2, which literally means to take that 2 value and put it in for x.
Uh-huh.
because
So
x is given. 2 is x.
so would I just multiply? Yeah. So 0 minus 4. I mean, no, it just equals 0. Sorry.
That equals 0, and that's the y value.
So y equals 0, and then you already know that x is 2.
2.
So then that's just it, right?
That's it. The other type of problem with the same function is I could ask you, where does f of x equal 8? And this time, this is the y value, not the x value. This is the y value. So you said 8 equal to 2x minus 4. So notice on the left here, you put the number in for x. And this one on the right, you put it on the other side of the equal sign.
Okay. So it's like opposite problems on opposite
Yes,
sides.
yes, yes, yes. Okay, now let's get back to what you wanted to work on today. Because I have no idea to know whether this is in going to be on your exam, but let's get
Yeah.
back to some factoring and see if we can get some of those in. All right. So here's your very first factoring question. It says to solve by factoring. So this is one that's in the right form. It's got everything on the left side of the equal sign. Okay.
Uh-huh. And is
there's
this the one where you're making like, I can't remember if you called it a tree or like a carrot or whatever, where it's like the two things breaking off.
So you want you want two numbers to multiply to 16 but add up to -8.
Uh-huh.
So like
So
1 and 16, but that
it wouldn't
obviously doesn't add up to 8, -8. 2 and
uh
8, 4 and 4. But they could also be negative.
mm-hmm.
So do any of these add up to -8?
Yes, the force.
Yes. So it becomes x minus 4 equals 0.
So you can have two negatives and it won't make the entire thing a positive.
No, so if you were to FOIL this, we can do that off to the right here. Uh-oh. Sorry, give me thing just rose up. So if we were to FOIL this, remember FOIL.
Oh, right, where it's like x squared and then minus 4x minus 4x.
Plus 16.
Mm-hmm.
Yeah, that gets you back to the original.
Okay. All right. So foiling is just showing like evidence for the problem almost.
Yeah, I mean, you don't need to FOIL because it says to solve by factoring. So you factor, and then you're not quite done. You have to set each factor equal to 0. You're going to set each factor equal to 0.
And then you just be adding.
Yes, so x equals 4, x equals 4.
All right. Okay, so that's.
So we're going to do another one like this.
Do you have to do anything else after that, or is that just kind of
Nope,
it?
that's it. You just circle your answer and say, I'm done. I got it.
All right.
Now,
And
very
then,
important is, sorry, go ahead.
oh, sorry. Do you ever use that solve by factoring to make a graph ever?
To graph it? No, probably not. This just tells you where it intersects the x-axis.
Uh-huh.
It just tells you that it hits at 4. You would need to know some other things to be able to graph it. Usually you make a table with quadratics.
All right, thank you.
Okay. So this is very important. There's got to be a 0 on the right hand side of the equation. Okay, that's really, really, really important. So look at this problem here. Is there a 0 on the right hand side of the equation?
No, there is not.
No, which means you want to make it 0. So you get all terms on one side of the equation. So this becomes k squared minus 9k plus 18 equals 0. And again, you're going to solve by factoring. So you have to find two numbers that multiply to 18 but add up to -9.
I guess -3 and -6.
Yep. So k minus 3, k minus 6 equals 0. So k minus 3 equals 0. K minus 6 equals 0. K equals 3. K equals 6.
So then with yeah, that's it. All right. Yeah, it's kind of funny. Like some of the problems after like you learn all these other things that go along with it. It's almost seems like wow, that's it.
Yep. Okay, so now the very first type of factoring that you're supposed to learn is called greatest common factor. So that will apply to the next couple of problems we're going to look at. So,
All right, the
so
GCF.
the GCF. So what you're looking for is there a number or a letter meaning variable, that's common to all three? So do you see that a 2 goes into all three of these?
Yes.
So you're actually dividing each of these by 2.
Okay. I actually have a question about this.
Yes.
So can I just divide
No.
the do I
Like if you want to be completely correct, no, you cannot just divide. Will it work
yeah.
most of the time? Yes.
So what if I wrote 2n, but I didn't include the 40 and I divided just the n's first?
No, you have to divide everything. Division
Okay.
is, I don't know what the right word is. You share, but you have to share with everything.
So is this what the last problem if so you just do the GCF greatest common factoring on it if it like if instead of 40 was 41 then that wouldn't work, right?
That's right. That's right.
So then that would be what the past problem was.
It's a variation on it. I mean, it's the harder, it's another harder version.
All right.
We're gonna do those where a is not 1, meaning the first term. But here you got to find two numbers that multiply to 20 but add up to -9.
Um 4 and 5, -4 and 5
Yeah, so you got n minus 4, n minus 5.
equals 0, and then n minus 4 equals 0, n minus 5 equals 0, n equals 4, n equals
Yeah,
5.
that's right. Okay, very good. Okay.
Um,
Okay. So ready for one more like this to try on your
yeah,
own?
I think so.
Let's
They
see
don't
here.
get a whole lot trickier than that, right?
I mean, there's other problems. We'll see. Sure. Um, yeah. Let me give you another one here to look at. Let's go 3a squared minus 30a plus 156 equals 0.
Um,
Nope. I'm sorry. This one does not work.
okay.
Let me change this up slightly. Sorry, I didn't realize what they were doing. Let's do that one. Yeah.
All right, so I guess you can divide those by 3, so then you'd have a squared minus 10a plus 25. And then -5 and -5 would make up for it. So then it would be a minus 5 equals 0 and a minus 5 equals 0. And then a equals +5 and a equals +5.
Good. Good. Yeah. So the the next type of factoring that we should talk about is difference of squares.
Mm-hmm.
And you actually already did this one, but let me just change one. Let's see, at x squared minus 64 equals 0. So difference of squares is a formula. It says if you have a squared minus b squared, and in your problem, you do have an a squared minus a b squared. Your b is 8. X squared minus 8 squared. Your x is a and your b is 8. The formula is it's a minus b, a plus b.
A minus b, a plus b. Okay, so then,
So,
uh,
so this becomes x minus 8. That's your a minus b, a minus b.
difference square. So then, so once you get to the x minus 8, x plus 8,
It's still equal to 0. I probably should have that
uh,
down on the next line, but you said each of those equal to 0.
uh-huh. It's kind of like the last one, but if there's not three, I guess, or if it's not like a
So
three
difference of squares, you're almost always going to have two terms. They can disguise it with more than two terms, but some cancellations have to happen.
uh-huh.
So, Leah, let me have you do another one here. Let's do, I don't know, let's go 9x squared minus 16 equals 0. So the game is to figure out what it is squared minus what it is squared, because that gives you your a squared and your b squared.
I guess 3x minus 4.
Okay, so that 3x is your a, 4 is your b, not the minus. The b is just the number in parentheses. So you're just writing out a minus b.
A plus b.
A plus b, yeah.
So then, would you be writing just okay? Wait. So if it's a plus and a minus, oh, because it's a minus b, a plus b.
Yeah.
So then, would you write like 3x minus 4 equals 0?
Yes.
And then 3x plus 4 equals 0.
Yeah,
So
because you're not done. You're solving. Solving means get x, get an x by itself.
So can x equal a fraction, or does it
Sure.
have to? Okay, so then I guess x equals 4/3 and negative 4/3.
Yes.
And this is called difference of a square.
Difference of squares, yeah.
Oh, of squares. All right.
Yeah. So let's try one here that requires you to do something else. Actually, this is not a great, well, we'll make it work. Yeah, let me do a different here. Let's go 5x squared minus 80 equals
Okay,
0.
so square it, and that's like the same as like a square root.
You should always look for GCFs first.
Okay. I guess 5 is a GCF for this problem.
Yes.
X. So then you have to write the numbers getting divided by outside the parentheses, and then
Yeah. I mean, if you want to pursue math at a high level, you don't want to just divide it out.
Yeah.
Just consider not doing that quite yet. I know it's because you'll get a problem later on where you'll divide out an X and you'll just forget that that's a solution.
Uh-huh.
I mean, it doesn't sound like it's me. I mean, the example I give is not very relevant, but you're missing out on one of the solutions.
Yeah. Okay. Yeah, so then I guess that would just leave you with x. I mean, you can still technically divide that, right? X minus 4.
You want to make this into difference of squares.
Okay, so x minus 4 and x plus 4. So you can just continuously break it down.
Yes, and then you said only the x terms equal to 0.
Okay.
Because there's
So
no
that
x
one
here.
shouldn't become 2 because there's nothing for it to get, like x plus 2 because there's nothing for it to.
It's not squared. It's down to the singular.
Okay. And then yeah, I guess x equals 4, x equals negative 4, and then
Yeah.
Did we do this last time we had any of our meetings, or?
Yes. This is not new. None of this is new.
Yeah.
But maybe it feels new. I mean,
Yeah, I guess
that's
it's like it feels new, but it's like I know how to do it. Like the
yeah.
the
I mean,
difference of squares.
I mean, did you drive at all when you were in Washington?
Yeah.
Okay, that's a bad example. I mean,
No, it's all good.
but there's just because you haven't done it in a while doesn't mean you
Yeah, it
forgot it.
can feel really different. Or like, Yeah, I guess an example could be like going back to my parents' car rather than
Yeah.
my parents or something.
So here's the last type that I'm seeing to solve this quadratic, and there's two approaches here. The first is the guess and check approach. And the guess and check approach works real well here because there's only one factor of 3.
Mm-hmm.
If there were more than one way to get a 3, we would do something different. But the guess and check approach, you work with the 6.
Oh,
And
in order to, you're still going for just the normal A, right?
yeah, so
Okay.
you would say like +2 +3 and see if that works. You would literally FOIL this to see if it works.
All right. So 3A squared plus
You
3.
actually just check the outer and the inner.
Oh, wait a second. That's smart, actually.
Yeah, it saves you some time. Now I've guessed real well because I do this a lot, so it's easier for me to
Yeah.
guess well, but you may not. And that's the difficulty with choosing, because this is option number 1. This is not what I showed you last year, but it is the direction they want you to go. Option number 2 is you take the 3 and the 6 and you multiply them.
Mm-hmm.
Okay, and then you do the same thing. You find all the pairs. Okay, but this time you're looking for the ones that add up to 11. So it's these two.
Mm-hmm.
And you write 3a squared plus, and I'm going to choose 9 first, 9a plus 2a plus 6. Notice that 9a plus 2a is 11a.
11A.
Okay, and then you factor by grouping.
So then that would be,
So see how there's a 3a in the first
yeah.
two?
And then, oh, and then there's just 2 for the others. So then you can
Yeah.
make it be
And then you factor out what's common with both. And notice you get back to the same place. Now, this is one where if you haven't done this in a while, you definitely want to go back and look. You have access to my YouTube channel, so you could just search for your lessons on the YouTube channel.
yeah.
And then you might even be able to just search. I put in keywords. You might even search for ones that say factoring and and then go back and just watch a lesson to find, or of course you can go back, you can just search the internet for
Yeah.
factoring videos.
Yeah.
But these are the harder type. These are the ones you're going to need more practice at.
Mm-hmm. Okay, so then with one like that, there's like steps built into it to even just get to where you can do the equation, sort of.
Yeah. I mean, now we're done. You said 3a plus 2 equal to 0. Said a plus 3 equal to 0. And then you solve. A is minus 2/3. A is minus 3.
Okay. Man, I can't believe people can just like come up with all of this and it makes sense.
Well, you did all this already, so I mean it's not impossible here for you to do
Yeah,
this.
or like just the people who like I guess invented algebra.
Yeah, I mean, but you can do this. So this is another problem on your worksheet. I've written it exactly the way it is on your worksheet. It's number 10, by the way. The problem here is there's an 8 over here. You have to get everything on one side of the equation. You can't even begin to do these problems until everything is on one side of the equation. Yeah. So you have to choose here. You're either going to use the guess and check approach or the 3 times the minus 8.
So it seems like for this one, the 3 times the minus 8 is probably the only way you can do this one.
You can guess and check. You got to be really good at guessing. Okay, so now you got to find two numbers that multiply to -24 but add up to -5.
I guess -8 and +3. Or
Yes. So the faster you can do that. So I'm gonna switch the order. I'm gonna go 3n squared plus 3n minus 8n.
Mm-hmm.
And the reason I'm doing that is because I can already look ahead and say, oh, those factor out nicely.
Both be like okay, so if I did put it the other way, it would just make it more difficult. So there's a more logical way because there's like
the
8s are together and then there's the ends, the 3. Yeah, there's like the 3s and 8s are together.
It still works, but if you see something, you should try to make it work if you can. Okay, now it's double factoring because you end up factoring out the n plus 1 from both.
So it would be n plus 1 because Right, because those the ones in the parentheses have to be the same. If
Yes,
I'm correct. Yeah. And then you just use the ones from the outside to make their own. N plus 1 equals 0, 3 minus 8 equals 0.
that's
And
right.
then, yeah, okay. All right,
Uh,
yeah, that makes a little bit more sense with the parentheses for inside and outside. I was a little confused when I was looking at.
as an aside here, if you were to go back and look at one of your earlier videos, you would be shocked how what you just said it was very clear and like you understood versus like a year ago, and there was like a lot of you were just like I don't understand. You'll see the maturation process along the
Yeah, I
way
guess
here.
that's pretty cool about your YouTube channel.
Yeah,
Yeah,
just other views. So in the time we have left, let's do square root property, I guess. We don't have a ton of time here to do some examples. So let me grab a problem. Okay. So this one says to use the square root property. Okay, and the kind of the base case is actually something like this. It would be like x squared equals, or actually make just a kind of tiny bit different. It would be like x minus 3 squared equals 36. You take a square root of both sides. Plus or minus is very important there. The square root undoes the square, so you get x minus 3 equals plus or minus 6. And it produces two equations again. X minus 3 equals 6. X minus 3 equals negative 6.
Mhm.
Okay, and then you solve them by adding 3, and you get 2 answers. Okay, so this is the nice case. This is the base case. You don't have that here, but it's the same process on the left here.
Uh-huh.
So you're going to take the square root of both sides.
So that would just make it m plus
On the
8.
and the left side is definitely m plus 8. On the right, though, the square root of 72 is not known.
That's
It's not
just another
nice.
number. Yeah.
So
Yeah, I have to
you have to break it apart using a prime factorization, unless you can see it. Sometimes you can see what it is. And you look for pairs. So there's a pair of
Mhm.
2s, there's a pair of 3s, there's 1, 2 left over. So for each pair, you bring a number out. So that because there's a pair of 2s, it's going to come out. Because there's a pair of 3s, it's going to come out. You multiply them. I'm going to write this down so you can see it later on if you need to. But
So
it
are you
becomes
multiplying all the numbers together?
just the pairs. So see how the 2
Okay.
comes out, and then you have that 2 left over.
So then that would be
So it's plus or minus 6 times the square root of 2.
which the square root of 2 is just
It's not friendly. We don't have
yeah.
anything we just keep that as. So you subtract 8 from both sides. Now this is where it's maybe a little bit unfamiliar. You actually put that minus 8 in front. So it's minus 8 plus or minus 6 square root of 2. Okay, it's not great. Like here's what this is. It's minus 8 plus 6 square root 2, minus 8 minus 6 square root 2.
Yeah, and you can't just make the 6 square root 2 become 3.
No, because the 6 is multiplying the root 2, the minus 8 is adding and subtracting order of
So once you
operations.
get the square root of 2, then you have to multiply it by 6.
Yes.
Okay.
Yes.
So I guess square root of 2. Wait, so that it's obviously not infinite, but wouldn't it just always be like 1 and 2? Or there'd be a pair of ones, I guess.
This is it. I mean, this is your answer, and this is. I mean, this is not
So
part
you,
of
so you
geometry.
can't really have just like a equals 0 to the end of that, sort of like that's just what you end with.
This is your yeah. This is x equals this. X equals this.
Okay, so that's just basically the equivalent of it because you're still having that plus and a minus from that plus
Yes.
minus. Like
Yes.
the other ones where it's like you have a, I guess, +5 and -4 or something like that. And then you have to x plus 5 equals 0, and then you have to subtract the 5 over and stuff like that.
Yes. 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 So final thought for you is that most answers in the real world are not nice. They're not friendly. They're more
Yeah, I just get lucky.
math class, you get lucky. Yeah. All right, Zach,
Okay.
well, that does take us to the end of our lesson for today. I really appreciate you scheduling. You may find you need another lesson. I don't know when your review is, but if you need to, please schedule. Be happy to help.
Yeah,
And
of course.
look forward to helping you this school year.
Yeah, thank you so much. You are definitely a savior when it comes to math. All
You're welcome. I'll see you next time.
right, see you, Matthew. Thank you.
Goodbye.